Hey guys, what's up, people? Welcome to the session. How are you guys doing? All great. What is up, people? Can you guys all hear me and see me clearly? Can you please put it on in the chat box? Hello, everyone. Hi, Aditya. Hi, Michelle. Hi, Kashish. Hi, Mujib. What's up, people? Welcome. How are you guys doing? All good? Hi, hello, good evening, people. What is up? All great, all amazing. Yes, super awesome, super excited. Today, I don't know, it's a little late though. It's about 9 o'clock in the evening, but nonetheless, when it's time to learn, it's time to learn, and we're here to learn something brand new today. So, very warm welcome to all of you guys out there. My name is Anoop, and this is your own Vedantu's 9th and 10th English channel. So, yes, before we get started, how are you people doing? All good? Yes, all awesome. How's the weather, by the way, people? I want to know what is the weather like in your place at this point of time, because here in Bangalore, though, it's been raining continuously and it's not stopping at all. Like today, we had a little break, but I'm guessing that it's going to start raining in the evening once again after some time. Not evening in the sense midnight. It's set to start raining again, but how's it going over there? Still raining. So cold, no? I know, exactly. Hi, Adarsh. Hi, Pravanjan. Hi, Aditya. What's up? Hello, Kishle. What's up? I'm great. How are you? Kanyakumari. Oh, it's raining in Kanyakumari also. Awesome. People enjoy the rain because, right before this, it was summer and we were complaining about that. Now it's raining and we are complaining about this. Is there something that we never complain about? Nah, not at all. We complain about everything. Just kidding. That's human nature. But nonetheless, a very warm welcome once again, people. I hope you guys are amazing. You're doing great. Today, what we're going to learn is basically one very important concept called as reflection. Now, why is this important? Let me answer that. Because people, this chapter of light contains two very important subtopics, or I can say two different parts. One is the reflection of light and the other is refraction of light. Under reflection, you're going to be studying about mirrors, and today we will be looking into what is reflection. What are the things you need to know about reflection? The fact of the matter is you've already studied about reflection in your lower grades. In your 6th standard, 7th standard, 8th standard, you have already understood what reflection is. So here we are going to look into a little, we're going to go a little deeper into it, understand the laws of reflection and everything. And after this, we will be getting into spherical mirrors. All right, so let me ask you this very important question. Are you people ready? Can I get a yes in the chat box? Can I get a oh yeah in the chat box? Yeah. My native place is Kerala. I stay in Bangalore, but my native is in Kerala. No rain in Delhi. Enjoy, Aditya, enjoy. Stay happy. I know it's little, it's like, how do I say it? It's bad if it doesn't rain. It's bad if it rains. It's I don't know. It's like a mixed feeling that we always have. All right, guys. So yeah. All right. So we'll get started with today's session. Now, before we get into today's session, in the last class, I'd asked you a very small homework question. This was the homework question. Basically, the question was, where is the world's oldest mirror located? And the answer to this question was in Turkey. And these are the homework rockers for today. Can we have a big round of applause for these superstars for giving the right answer? First one is Michelle, who has actually given the right answer. Michelle is here also. Congratulations, Michelle. It is actually in Turkey. It is the oldest mirror is about 8,000 odd years old, or about 4,000 BCE, and it is actually located in a place called as Anatolia, which is in modern Turkey. It's called as this place is called as Anatolia. We have Sneha also given the right answer. Congratulations, Sneha. Fantastic job. Then we have Crazy Guy. Then we have Sanjeev, and also we have Saraswati. Congratulations, guys. Fabulous job. A big round of applause to all of these superstars for giving the right answer. Today also I have a homework question, so whoever puts it down in the next session, you would have your name in the next class just like this. All right. So if you want to see yourself in the next session, put it down in the comment section. All right. Okay, guys. Now with that said, let's get into the topic for today. Now, as always, we'll start the session with a fun fact. The fun fact for today is this, people. Mirrors not only reflect light, but can also reflect sound. Why? Because mirror is an object. And if you talk about any object for that matter, sound gets reflected from no matter what sort of surface. So whether it's a mirror or not, sound will still undergo reflection. So with that logic, mirrors can not only reflect light, but also it can also reflect sound as well. Not only that, in the ancient times, people used to use even water as mirrors. Now, you'd have probably heard about the story of a lion jumping into a well which was tricked by a rabbit. Do you guys remember that story? A rabbit who doesn't want to die tricks this lion into jumping into the well and killing itself because it saw its own reflection. Now, this is not something which is taken just as a fairy tale. This is actually something that is followed in the past. With that said, let's get into the topic for today. So here's the question, people. For all of you guys out there, now who is watching the session on the YT channel right now, YouTube channel right now, please join the session through the link that is given in the description. You can directly join the session because we have a lot of quiz questions today. So if you guys want to take part in the quizzes, you have to be here on the platform. So please click on that link and join for free. Again, there's no need for you to pay. You can just join in and take part in the quizzes as well. Okay, let me ask you this question, people. How are you guys able to see the objects around you? Can you put it on the chat box? Now, what are the things that you need in order for you to see the objects around you? Put it on the chat box. What are the things that you need? All right. Kamal's like directly reflection because the topic itself is reflections, or reflections are all right. Light, eye, yes. Anything else that you need? Hands, no. No hands. Legs, no. You don't need any of that. Okay. Nose, to smell the light, no. Tongue, to taste it, no. All right. Light, no. All right. Now, for all those who are telling light, one of the most basic things that you need in order for you to see things is eyes. Absolutely, there's no denying it. You need your eyes to receive the light. The eye is basically a sensory organ which can actually receive the light and help you attain or see the information around you. But as you guys rightly mentioned, along with your eyes, you also need something called as what? Light. For example, imagine a well-lit room. A beautiful room with sofa, beautifully painted walls, beautiful paintings, lamps and whatnot. Full contemporary work. They spent a lot of money on this, all right? And there's a dog also, sad little dog sitting on the sofa. Now, one thing that you notice in this picture is very clear that all of this you're able to see because there is light coming through the windows, right? Or there is light turned on. Now, if it wasn't for the light, you would not be able to see anything that is there in this room. Now here, even with the image being dimmed down a little, you're still able to see a little bit of reflection. You're still able to see a little bit of shadow here and there. But the fact is, people, if you enter into a dark room, it is not that you don't have your eyes at that time, right? When you enter into a dark room, do you leave your eyes at the doorstep and then walk into the room? Is that what is happening? Imagine you're walking into a dark room. Do you leave your eyes at the doorstep? No, you don't. You are carrying your eyes wherever you go. But why are you not able to see? The reason is because of this one small thing called as light. Because if it wasn't for light, 99% of the things that you have around you, it would not be visible. Now just think for a second, just think for 1 second. All of you guys might be sitting in a room right now, or you might be traveling. Now for 1 second, imagine the power goes off, or the battery in your car runs out, right? You're stuck in the middle of nowhere. You would literally be able to see nothing in your room, right? Because all of the things in your room right now, you're able to see only because of the light that is coming from the tube lights. As simple as that. So understanding how it works, why are you able to see, is something very, very important. So yes, with that said, let me ask you a very simple quiz question, people. The object which emits its own light are known as what? Technically, what are they called as? Are they called as luminous objects? Are they called as non-luminous objects? Are they called as opaque object? Or are they called as translucent object? Objects which emit their own light, which can produce their own light, are known as what? A beautiful question, super duper easy. Go ahead and answer this, people. Is it luminous, non-luminous, opaque, or translucent? Like, jaldi kar do ji. I'll start the quiz in 3, 2, 1. Let's go. 30 seconds. Go ahead and rock it, rock stars. Let's go. So when the light falls on the object, arre, Manladi, absolutely. How are you doing, Manlad? Long time no see. I know a little bit of Tamil. Not too much, but yeah, I can manage. Alright, let's go. I want all of you guys to answer it up. Don't just sit there. You're here to learn something new. So let's make it happen, right? You're spending 30, 40 minutes of your time. Let's make it happen. Let's utilize that time. Awesome job, people. Kamal, Aditya, Michelle, Swati Meena, Harini, followed by Pami, Ashta, Sneha, Shubh, and Jenny. Fabulous job. Fabulous job. All of them in the top 10. And is that 100%? Yes, it is. Super awesome, people. Super awesome. That is just amazing. Let's have a dole for this. Fabulous job, guys. 100%. How are you guys feeling? Huh? Would you guys like to give an interview? How does it feel to score 100% in the first quiz question? Huh? Very happy? Huh? Obviously, you have to be. You have to be proud of yourself. 100%. That means everyone in the class got the right answer. Fabulous. Bahut maza. All right, that's good. Keep it up. All right, absolutely fantastic, guys. Exactly. It's nothing but luminous objects. Anything and everything that can produce or emit its own light are called as luminous object. For example, the sun, the tube lights, the bulbs, the candles, all of these are luminous object. And this luminous object is what is enabling us to see things around us. Imagine without the sun, how would your day be? Dark. You'd not be able to see anything. So what are these things doing? What is this light doing to us? The light that is coming from the sun is enabling us to see things through a process known as reflection. So what is reflection? How do you define reflection? Reflection is nothing but the bouncing of a ray of light back into the same medium. Now, what do I mean by that? For example, guys, simple, I would like to actually show this as an experiment to you people. I don't know how much I'd be successful doing this, because I want to show you this. I'm going to turn off all the lights for 1 second, people. Just give me 1 second of your valuable time. I'll just turn off all the lights and try to show you what do I really mean by this bouncing back of ray of light. All right, just give me 1 second of your valuable time. I'll just quickly turn off all these lights that I have in my room for 1 second and then try to show you what I really mean by that. All right, just give me 1 second of your time. All right, pitch darkness. All right, pitch darkness. I'm just gonna bend my camera down a little so that you guys can see this. Now, here with me is basically a laser light. I don't know if you guys can see this, people. It is not visible at all for some reason. All right, but I hope you can see it to some extent. Okay, this is just pitch darkness. But what I'm trying to show you is this, people. Now, if you look over here, there's a mirror. Now, reflection is nothing but this bouncing of ray of light. Let me just enlarge this for a second so that I hope that this gives you better visibility, but I don't know how far this is working because the camera can only do so much justice to this. But yes, I don't know if you can you guys see this at least to some extent? Are you able to see? Yeah, I know it looks like booth, but yeah, I know it looks scary and all that, but I hope that it's at least a little visible. Now, what I'm trying to show you is, people, this is what is known as reflection. I know if you guys can see the rays of light very clearly, but yes, now to some extent you can see it over here now. Now, what I'm trying to say is this, people, reflection is nothing but this bouncing of ray of light. What is happening is that the light is basically coming from this laser that you see, all right? So there's a laser in my hand, that is a source of light. What happens is that when it comes and falls onto this mirror, it basically bounces or jumps back into the medium. In a sense, the light is basically coming from air and getting reflected back into air because of reflection. This is what is known as reflection. I don't know if I was able to get anything through the camera, but yes, I was trying my very best. But there's only so much visibility that can happen through this. But yeah, I will put it up as a YT shot if possible later on, right? But yes, this is what is reflection, guys. A reflection is nothing but the bouncing of ray of light from any sort of surface. Now the fact is there are two types of reflection. Reflection in which you can see the reflection that happens on a smooth surface and the reflection that happens on a rough surface. Now the kind of reflection that you see over here is a smooth surface. If you can see over here, you're clearly able to see the image. Now if you notice this for 1 second, you can actually very clearly see the the mirror right in front of me. You can see the camera, you can see the laptop. You're able to clearly see everything on this. This is what is called as a regular reflection. So what you have right now is a very smooth surface. Mirrors in general are very smooth. They don't have a lot of irregularities. So the kind of reflection that happens on this is called as a regular reflection. Now what do I mean by regular reflection is that in a smooth surface, when the rays of light are coming and falling, imagine there are 3 rays of light coming and falling on this mirror, all right? And all these rays of light are parallel to each other. Now what happens is that after reflection also, these rays of light will be parallel to each other. This is what is called as regular reflection. Now what is so special about this regular reflection is that when you have regular reflection like this, you can clearly see the type of image. You can see the image. This is what is called as regular reflection. But now tell me one thing, people. How are you guys able to see me? What is the reason? I've asked you this in the previous session also. Let me ask it one more time. What is the reason that you guys are able to see me? What is the actual reason for that? What is the reason that you guys are able to see me? Again, because of light. Because why? Because I am reflecting the light that is falling on me, isn't it? I'm able to reflect the light that is falling on me. But the kind of reflection that happens on my body is called as a diffused reflection. The reason why it's called as diffuse reflection is because my face or all these objects that you see are not as smooth as a mirror. It is, it has a lot of these kind of, a lot of irregularities like this. It is a rough surface. So what happens over here is that when these rays of light comes and falls on a rough surface, let's say all these three rays of light were parallel to each other, but after reflection, these rays of light will go in different direction. So because of this, the type of reflection that you get over here is known as diffused reflection. This is known as diffused reflection, and this one is called as regular reflection. All right. So this is what you need to understand, people. Reflection happens from all the objects. It doesn't matter whether it's small, big, whether it's shiny or not. Everything reflects light. But again, the type of reflection depends on what sort of surface the light is falling onto. So if you have a smooth surface, you have a regular reflection where you're able to see the image and all of that. When you have a rough surface like this, what you get is diffused reflection. Now, this is exactly what I was trying to show here. Now, there are a few terminologies that you must be aware of when you talk about reflection. The first one, guys, is if you have a mirror and let's say this is a laser light and light is coming from this laser. The light coming from the laser is called as the incident ray. This is known as the incident ray. Why? Because it is going and incidenting or falling on that mirror. And the light ray that gets reflected back or gets bounced from the surface is known as the reflected ray. So this one here is the reflected ray and this one is the incident ray. Now, what you need to also understand is, people, at that particular point, wherever the incident light is meeting, what I'll do is I will draw a straight line perpendicular to the surface. Now over here also, again, if I turn off the light also, there's no point because you barely can see anything with all these lights on. But I'll try my best again. So again, if I turn off all these lights for 1 second again, people, now what happens is I'll just turn it off for 1 second again and try my very best to show you guys whatever is possible. Now here, this ray of light, right? This ray of light that you see over here comes and falls on this surface, right? Now what happens is, people, exactly at that point, can you guys see a dark spot on this mirror? Are you able to see a dark spot on this mirror, right? Again, you're not able to clearly see the light, but you can see a dark spot, right? Now that is the point where the incident light is coming and falling. On that particular point, what I'll do is I will draw a line perpendicular to the surface. Perpendicular means 90 degrees to that surface. That is what is known as the normal. So that is what is called as the normal. Normal is nothing but a straight line perpendicular to the surface. It's a straight line perpendicular to the surface. That is what is known as a normal. Now, once you draw the normal, the angle that is formed between the normal and the incident ray is called as the angle of incidence. This here is called as the angle of incidence, and this one that you see over here is known as the angle of reflection. Now, why is all this important? Because you're going to be using all of this in your exam as we go ahead. In your exams also you'll be using this, because your whole chapter of light basically relies on understanding these basic concepts, and more importantly, you'll also have some questions based on it. All right, so please remember this, people. The incident light is nothing but, or incident ray is nothing but the light that is nothing but this light. All right, so if I turn on this one, this is the source of light, so this is the incident light. Once it falls on the surface, it gets reflected back. That is called as a reflected ray. So incident light, reflected light, or incident ray and reflected ray, and the angle that is formed between the normal and the incident ray is called as angle of incidence, which is represented by the letter small I, and the reflected ray, the angle between the reflected ray and the normal is called as angle of reflection, which is represented by the letter R. And the most important thing you need to understand is that, people, there are certain laws that these rays of light follow. The first law of reflection is this, people, that the angle of incidence and the angle of reflection will always be equal to each other. It'll always be equal. In that sense, if let's say there's a ray of light coming and falling on a surface and the angle of incidence is 30 degrees, angle of reflection will also be 30 degrees. If let's say angle of incidence is 45 degrees, then what will be the angle of reflection, people, in the chat box? What will be the angle of reflection? If angle of incidence is 30 degrees, angle of incidence is reflection is 30 degrees. If angle of incidence is 40 degrees, what will be the angle of reflection then? What will it be? 45. That's all, as simple as that. As simple as that. Okay, let's say angle of incidence is 0 degrees. Then what will be the angle of reflection then? If angle of incidence is 0 degrees, what will be the angle of reflection? 0. As simple as that, people. It's as simple as that. So what I'm trying to say is this, people. This is something that every ray of light follows. It doesn't matter whether it's a smooth surface or it's a diffuse surface, it's an irregular surface or irregular surface. It really doesn't matter. It will always follow this law. Now you might be wondering, sir, okay, let me ask you this question. Do you think the ray of light that is coming and falling on this rough surface follow this laws of reflection? The first law of reflection that I just talked about. Do you think it follows it, or do you think it doesn't? Like, it only applies for smooth surface. According to you people, what do you think? Yes? Pakka? No? Swati is like no? No, Kamal? Absolutely, right? Why? It doesn't make sense at all. The answer, people, is that yes. The fact is, even if it's a rough surface, it'll still follow laws of reflection. I'll tell you why. Imagine this is the ray of light. All right? Now, to this point, how will the normal look? This is the surface. This is the surface. So to that particular surface, this would be the normal. This would be the normal. So what is angle of incidence? Angle of incidence is nothing but angle formed in the incident ray and the reflector and the normal. And angle of reflection is nothing but in the angle formed in the reflected ray and the normal. So don't you think those two angles are almost equal in this scenario? Yes or no? What I'm trying to say is this, people. It doesn't matter whether it's a smooth surface or if it's a a rough surface. It really doesn't matter whether it's regular or irregular reflection. It really doesn't matter. incident light or the rays of light will always follow this law of reflection. And the second law of reflection states that the incident ray, the reflected ray, and the normal will all lie on the same plane. Now, what do I mean by that? I'll just show you again, with that simple experiment. So, for example, people, let's say there's a ray of light coming and falling on this mirror now. Now, what you have to understand is this, people. The incident ray and the reflected ray here, you clearly can't see it. You can't even know if I've turned it on or not. Now, what I'm trying to say is this. All of these will lie on the same plane. Now, what do I mean by plane? For example, people, let's say I introduce a paper now. Let me just again try to show this to the best of my abilities. I'm trying it, but then again the camera quality is pretty bad, people. It's a 1080p camera, so there's only so much it can take. All right, so I'm just gonna turn off the lights once again and try my very best to show the most practical way possible. So I'll just I'll just try my very best over here. So let's say, people, this is my this is my light. All right, so let's say there's a ray of light coming and falling onto it. All right, okay, now what I'm trying to say is this, people. This is the incident ray, this is the reflected ray. All right, this is the incident ray, this is the reflected ray. Now, according to the first law or the second law of reflection, what it's trying to say is that both the incident light and the reflected light should lie on this paper itself. So if I introduce a paper, plane is nothing but a 2D figure. All right, plane is nothing but a 2D figure. So what I'm trying to say is, if I were to place this paper, all right, both the incident light and the reflected light should lie on this paper itself. One cannot be outside the paper, in the sense incident light cannot be in front of the paper and the reflected light behind the paper. It should both lie on that paper itself. It should both lie on that paper itself. I don't know if it's making sense. I don't know if you can clearly see it or not. But again, I'll be putting out a lot of YT shots on it. But yes, just for the sake of it, at least in this session, I hope it makes sense. So what happens is, people, a plane is nothing but a 2D figure. All right, a plane is nothing but a 2D figure. So a plane can be nothing but a paper, because paper has very less thickness, right? It has very less thickness. So because of this, it can be considered as a plane. So if I have a ray of light coming and falling on a surface, all of them, the incident light, the reflected light, all of this must lie on this paper itself. The incident light cannot be in front of the paper and the reflected light behind it. That is not possible. If both of them are behind, then it's fine. If both of them are in front, it's fine. But they should lie on the plane itself. They cannot be outside the plane. One is on the plane and one of them outside the plane. That is something which is not possible at all. All right. So this, my friends, is what is the second law of reflection. And these two laws of reflection are followed by every single ray of light. Doesn't matter whether it's a smooth surface or a rough surface, regular, diffused, it really doesn't matter. At the end of the day, every single ray of light follows these two laws of reflection. Very important to remember this. The fact is, you've already studied this in your lower grades. You would have forgotten it by now. But this session was there to remind you guys of the concepts that you've studied in the past. All right. Is it clear, people? Shall we move on to the quiz questions then? All good. So that is the end of the teaching part. That is all I had to teach for today. I hope you got, some idea or some sense of what I was trying to teach you, people. I hope it's clear. Well, with that said, let's go on to the quiz questions now. Do a couple of quiz questions. Thanks a lot, people. And then see and test if you have really understood or you're just going with the crowd. The first question is this, people. The laws of reflection holds good for plain mirrors only, convex mirrors only, concave mirrors only, or all mirrors irrespective of their shapes. When you talk about the laws of reflection, on which of these surfaces do you think the laws of reflection holds true? I'll start the quiz in 3, 2, 1. Your time starts right about now. Let's go now. Let's go, people. Let's go. Hi, Suman. What's up? How are you doing? I'm not able to see your chats at all, people. So my signs, I'm good, Armanjot. How are you, da? Is it? Awesome, da. Congratulations, Armanjoti. Party. Thank you, Michelle. Thank you, da. So tomorrow, my 10 years journey of school will finish. Zubair. Sad, no? Don't you have some, this thing and all, farewell and all that? You'll have, no? Farewell, I think, has farewell already done? I think farewell would have been done already, no? But because of COVID and everything, I don't know. Like, you should have at least one farewell. Farewell to Banta hai. After 10 years of school life, you should at least have that. Anyways, Harmanjot, Sneha, Kamal, Aditya, Michelle, and Swati, congratulations, fantastic job. We have Khan, Ashta, Sneha, and Pami. You chose the wrong answer apparently, but it's okay. 57%. I have mentioned this a billion times already. It doesn't matter what sort of surface light falls onto. It does hold true. It doesn't matter whether it's, see, all this while the mirror that I have been using was actually a convex mirror. Getting it? All this while I did not use a plain mirror. This was actually a convex mirror. And you could see that it was holding true, right? Angle of reflection, what to say, incidence. And you could also see that they're all in the same plane. So it really doesn't matter whether it's plain mirror or if it's, a curved mirror. It doesn't, a spherical mirror, it doesn't matter because it does follow these two laws of reflection. Doesn't matter what, all right? Second one, light travels fastest in which of these medium? Now, this is basically a general question, not something that we've learned today, but give your best because you already know the answer for this. Does it travel the fastest in water? Does it travel the fastest in air? Does it travel the fastest in glass? Or does it travel the fastest in diamond, Hira? All right, 10 seconds. Let's go. Arey, Harmanjot, congrats. Big people. Senior. All right, I'll start the quiz, people. Let's start the quiz in 3, 2, 1. Let's go. Let's go, guys. Senior and all. Your senior and all is there in the chat box. My God. All right, people. All right. Let's go. Quickly. Let's go. Done. 19 more seconds. All those who have not answered yet, please answer the question quickly, people. Light travel the fastest in which of these? Water, air, glass, or diamond? 10 seconds. And we will begin. 5 more seconds. 4, 3, 2, and 1. Time's up. Fabulous job. The right answer for this question, without a doubt, is air, people. Light travels the fastest in air. Light travels a lot more slower in water. In comparison, a diamond, it'll be the slowest, after which it'll be, glass, where it's the second slowest. Third slowest is water. And finally, we have air, where it is the fastest. Kamal, Sneha, Aditya, Michelle, Harmanjot, Swati, Ashta, Kirti, and Riddhi. Fabulous job. Alia, it's all right. Ayla, no worries. 92%. Fantastic, guys. Fantastic. That's what I'm talking about. 92%. Balloons. Because you guys are stars. That's right. You guys will fly up in the air just like that. That's why. Fantastic job. 92% of the class. Absolutely, guys. The right answer is nothing but air. Light travels the fastest in air with a speed of 3 into 10 to the power of 8 meter per second, or 2.9 into 10 to the power of 8 meter per second. All right, here's another one. The angle of incidence I and refraction R are equal in a transparent. Okay, now this is another question which we have not studied today. But again, give it a shot if you're able to answer it or not. It's not something which you have looked into it. So I'll just repeat the question one more time. The angle of incidence I and refraction R are equal in a transparent slab. When the value of I is 0 degrees, 45 degrees, 90 degrees, or it depends on the material of the slab. I'll repeat the question one more time, people. The angle of incidence I and refraction, not reflection, refraction R are equal in a transparent slab. When the value of I is what? In what case will they be equal? Options are 0 degrees, 45 degrees, 90 degrees, or it depends on the material. Let's go, people. Let's go. Try your best. Again, you've studied about a little bit of refraction also in your lower grade, so I'm hoping that you know the answer. I'll start the quiz in 3, 2, 1. Let's go. Come on. Let's go. All right. You have 15 seconds. Let's go. Okay, another 4 more seconds. 4 more seconds. Let's go. I know, I know. How is 11th standard, by the way? Tell your juniors, how does it feel to be in 11th? Kamal, Akshit, Aditya, Sneha, Michelle, Ashta, and Pami. Fantastic. Habibullah, Harmanjot, and Swati. It's all right, no worries, happens. With that said, 47%. That is the lowest we have gotten so far. Not bad. I mean, could have been a lot better, but it's okay. It's okay. Still, for a job well done, confetti shots. Yes, because 47%. And it's a beautiful staircase, no? 47, 23, 17, and 11. Fantastic job, guys. Fantastic job. Overall, the right answer, the answer for this question, guys, is actually option number A. Why? Because people, again, I wish I could show you guys. I have a glass slab with me, but it's not working so well because of the fact that the camera does not pick up all of this. So I'll do one thing. I'll show this as a YT shots again. We'll be starting with the experiments and all of that. So that time I'll show you guys. So the thing is, people, a glass slab is nothing but, a glass slab is nothing but this one, all right? It's nothing but a block of transparent glass. This is what is a glass slab, basically, all right? Now, when you talk about this type of surface, right, it is not reflection because it's not silvered. Unlike a mirror, it's not silvered. So if I were to shine light through it, light would clearly pass through it. I don't know if you guys can see this again. It's not possible for you to see because of all the lights and everything. But yes, light would basically pass through it. That is what is called as refraction. Now, if angle of incidence and angle of refraction has to be equal, then the angle of incidence has to be 0 degrees. In other words, light has to be incidenting exactly at normal, exactly normal. If the light is incidenting exactly normal, again, if I turn off the light, I'll just try my best to show this again. Again, there's no, I don't know if I can show it, but I'll do my very best again. So you see this? If you notice very carefully, if I keep the light exactly at 0 degrees, exactly normal, you can see that light is almost passing through straight through the glass slab. I'll just try to enlarge this a little and I'll try to show it. If you can you guys see this? Light is basically passing through straight. Exactly at normal, it's passing through straight. But if I place it at an angle, can you guys see this? Angle of incidence and angle of refraction is a little different here. Here the light is basically bending a little, all right, it's bending a little. But if I keep it exactly at normal, you probably can see that it's basically passing through straight without any refraction whatsoever. Or you can say that the angle of incidence and angle of refraction in that scenario would be equal. And that happens only when angle of incidence is 0 degrees, all right? When angle of incidence is 0 degrees, that's when that basically happens, all right? Okay, people, with that said, moving on to the last and the final question for today. When light falls on a smooth, polished surface, most of it is reflected in the same direction, is reflected in a different direction, is scattered, or is refracted into the second medium. When light falls on a smooth, polished surface, what happens to it? Light gets reflected in the same direction, light gets reflected in different direction, it gets scattered, or it gets refracted into the second medium. Fabulous question, super easy one. I will start the quiz in 3, 2, 1, let's go. Dharamveer ji, my Hindi is hopelessly bad. हमारा हिंदी तो बहुत खराब है. हमें सिर्फ जा सिमरन जा जी ले अपनी ज़िंदगी बोलना आता है without making mistake. Sorry. That's all I know. I'm really very sorry. Can't help it. All right. Done, people. Almost done. 3 more seconds. All those who have not answered, please answer the question quickly. With that said, let us look into the final fastest fingers list. Sneha, Akshita, Aditya, Michelle, Kamal, Ashta, Pammi, Riddhi, Jenny, and Swati Meena. Fabulous job, fabulous job. 64%. Not bad at all. Could have been a lot better though, with a little bit of confusion here and there. However, the answer would be in the same direction because it's a smooth surface, so it'll get reflected back in the same direction. But it's a rough surface. If it's a rough surface like you see over here, then it would get reflected in different direction. But if it's a smooth surface, then it would be pretty much get reflected in the same direction. All right. So that is it, people. But we are not done yet because I also have a homework question for you people. All the homework rockers, once again, if you guys want your name to be published in the next session, you need to put down the answer for this in the comment section. The question is, an object is placed at a distance of 0.25 meters in front of a plane mirror. The distance between the object and the image will be what? I'll repeat the question one more time. An object is placed at a distance of 0.25 meters in front of a plane mirror. The distance between the object and the image formed will be what is the question? Go ahead, Put it down in the comment section. Let's see how many of you guys can get this right. It's a very simple one, but I'm pretty sure a lot of you guys might go wrong in this here and there. Let me see if you guys can get this right. But nonetheless, people, here is your final leaderboard for today. Let's have a drum roll for the leaderboard. Leaderboards, here it is, people. The final leaderboard for today. We have Sneha, who is the winner. Sneha and Aditya, congratulations. Sneha and Aditya Kashyap, 400 points each. Second is Kamal with 380 points. Third is Michelle. Fourth is Swati Meena. Fifth is Ashta and Shubh. Sixth is Sneha. Seventh is Harmanjot, Pami and Akshit, followed by Alia, Kirti, Habibullah and Harni. Fabulous job. Super awesome. Keep up the good work, guys. Keep up the good work. Whoever is at the bottom now, I'm pretty sure you guys will make it to the top next time. So keep trying, keep doing your very best. Now with that said, people, if you guys enjoyed today's session, hit that like button, subscribe to the channel, because we're not done yet. We're not done just yet, because I also have something very exciting and something which is very, very fascinating to tell you people as well. Hit the like button, subscribe. What is it? 23? Sharam karo. Putting all this effort, showing you light, turning off all the light and everything. Hit the like button, subscribe to the channel. All right. Make us happy, make us proud. All right, now what you have to do is, people, if you guys have enjoyed today's session, and if you want more such sessions like this, where you understand all of the concepts, and where the concepts are taught in a manner where it's made sure that it's shown in the most practical way, and we try our very best to make it, as easily understandable as possible. And you guys want to enjoy more such sessions every single day for all the subjects: physics, chemistry, bio, math, English, social science, all 6 subjects. Here is an opportunity for you guys to enroll into the Pro Light CBSE courses for 2022-2023, where you'll be giving your exam in 2023. This link that you see in the description right here, this link that you see at the bottom, will take you to the web page of Vedantu, where you can actually see that the entire course price of the whole year, with all the 6 subjects, with test series and assignment, with Tattva book, which is our fabulously made question bank, where you get some amazing set of questions. You can ask your seniors how well Tattva books have been made. All of that with test series, with doubt solving, all of that for a price of just 4,500 rupees. And this is not for a month, not for a week, not for 2 months, not for 3 months. This is for the entire year, that you're getting the entire year course for just 4,500, which is a fabulous deal. The course is set to start. The next batch is starting from 23rd of May. So you have about 5 days time to make this choice. The language it'll be taught in is English. All the 6 subjects, live doubt solving, live leaderboard and quizzes, test series and assignments, master teachers of the best kind would be teaching you all of this for 4,500 rupees. The base price of this is 5,000 rupees. But once you click on buy course, you would automatically, the coupon code would be applied. My coupon code is AME Pro. Yes. And this coupon code would give you 500 rupees discount. Who doesn't like discount? With that discount, the price comes down to 4,500 rupees. Now, if you don't want this 500 rupees discount, please click on remove. Yes, click on remove and pay that 500 rupees also. It's absolutely fine. But if you want that discount, enter my coupon code AME Pro and see the magic of 500 rupees getting cut down from that list and getting the price down to 4,500 rupees only. All of this you're getting for 4,500 rupees, which is a fabulous deal, because you're getting everything that you want for the entire year, with the best of the best master teachers, in-class doubt solving, post-class doubt solving, interactive classes. All of this is what you're getting for this price range. Never before, never again. Now, the price of this would go up in the next couple of days also. So before that happens, before you dig your own grave, make sure you enroll yourself into it. All right. So that is it, people. That's all from my side. Thanks a lot for joining today's session. I hope you enjoyed it. I hope this was a little interesting. I hope I did justice. I hope you guys found this session worthwhile. Thanks a lot for joining, people. Have a fantastic day. See you all in the next one then. Bye, people. All right then, take care. Thank you so much, Michelle. Thank you. I'll catch you guys in the next session. Take care of yourselves. Have a fantastic evening. See you all in the next session. Until the next time we meet, this is Anoop signing off for the day. Adios, people. Bye. Good night. Konnichiwa, arigato, whatever, and ciao, and peace out. Bye. See you all. Take care. Enjoy yourself.